Hi everyone, in continuation with our video classes on the subject of sequences and series. Now today's topic is arithmetico-geometric progression, or simply we call it AGP. Now in the terms of an AP, be multiplied by the corresponding terms of a GP. Then the new progression that is obtained is said to be the arithmetico-geometric progression, or simply we call it AGP. Like you know, A plus D into R, A plus 2D whole into R square, A plus 3D whole into R cube, and that is dot up to. This is an AGP. Now, the inner term of this AGP is definitely going to be the inner term of this arithmetic progression, that is A plus D, A plus 2D, A plus 3D, and so on. So, inner term of this AP will be A plus N minus 1 whole into D. This is a bar, means a bracket. So, A plus N minus 1 whole into D into R to the power N minus 1. That will be equation 1. Now, this sequence Tn is an AP when if R equals to 1, you see clearly it becomes an AP. And this will be a GP if D is equal to 0, you see this will be becoming a GP. As for example, if I have taken this sequence 1, 3, 5 and minus 25, apparently first three terms 1, 3, 5 seems to be an AP. But when you are including this minus 25, definitely it is not going to be an AP, and you cannot find the GP also here, but it is an AGP. How? Because with A equals to 1, D is equal to minus 2 by 5 and R equals to 5. Now you place the values, and you get this to be in AGP. Okay. Now we will be going to find the sum of n terms of an arithmetico-geometric series. First of all, I must say that this is just a procedure that you want to follow. Do not use the formula finally in your sum, okay? It will be rather cumbersome to remember this formula, and also it is not needed. Ratomat. Don't mug up. Now, let the sum of the AG series be Sn equals to A plus D into R plus A plus D into a square plus dot. This is the nth term. Now what you will do is that you have to multiply this Sn with R. Then each and every term of the Sn will be multiplied with R. This A becomes AR, shift it 1 plus on the right. Next is A plus D into R square, and so on. Now subtract it. Subtracting we get Sn common 1 minus R equals to A plus dr square, okay, and this way. And the final term keeps the same, with a minus sign. Then segregate it. A plus, first term we have left. Then take dr common. Then it becomes 1 plus R square plus so on up to R to the power n minus 2. Why? Because once again we have left from 1 and this one term 2 times. So this becomes R to the power n minus 2 minus this term keeps intact. Therefore A plus, this is our GP. So dr whole into 1 minus R to the power n minus 1. You are just using the formula, nothing else. By 1 minus R minus the last term. And that equals to have segregated it. So dr by 1 minus R minus D into R to the power n by 1 minus R minus the last term. This way, this was 1 minus R equation. I need Sn. So Sn equals to, for each and every term on the right hand side, you want to divide it with 1 minus R. Thereby it becomes A upon 1 minus R plus dr upon 1 minus R square minus D into R to the power n whole by 1 minus R square, and the final term is divided by 1 minus R. This is just the way we do it. Do not mug up once again, I say you. So we worked out that the Sn of the AG series was this. Now what if the sum of an infinite AG series? Okay, let mod R less than 1, that is R is lying within plus 1 to minus 1. It's a real fraction. Then R to the power n will be tending towards 0, and similarly R to the power n minus 1 will tend towards 0 when n tends to infinity. Therefore, this Sn, now we will be saying this to the S infinity, is equal to the first term we will be retaining a by 1 minus r plus dr by 1 minus r, and the rest of the terms will be nullified because they will become 0. Right? So easy. Now let us do some illustrative example. Find the sum of this thing over the AG is given. So clearly it's an AG. And let the sum be Sn. So Sn equals to 1 plus 2x plus 3x square plus 1 up to the Tn term. Now why did you multiply both the sides with x? So x into Sn becomes this. Now if you subtract this two, you get 1 minus x whole into Sn is equal to, we are keeping along the 1 plus this subtraction will be the result of this thing, and this is definitely obtaining minus 1 terms, and this is the last term, that is minus x into Tn. That is, this will become 1 plus, this is on GP, the first one x, and the common ratio is x. So x into 1 minus x to the power in minus 1 upon 1 minus x into Tn. Let it be equals to 1. Now this Tn. Now this Tn. Tn of the Tn of what? Tn of this AG. What is that? Now the Tn of the AGP, that equals to nth term of the sequence 1, 2, 3, etc. That's an AP. Multiplied by nth term of the sequence 1, x square, and so on. So this will be 1 plus n minus 1 into a 1 simple AP, and this 1 into x to the power n minus 1. So plug it up. If you solve it, become n into x to the power n minus 1. Now we will be putting this value into the equation number 1. Then you will get that 1 minus x whole into Sn is equal to 1 plus this thing x into 1 minus x to the power n minus 1 by 1 minus x, and the last term being x into n into x to the power n minus 1. That is why simplifying you will be getting that 1 minus x plus x minus x to the power n by 1 minus x minus n into x to the power n, x to the power 1, this is added to it, x to the power n. So simplifying 1 minus x to the power 1 minus x minus n into x to the power 1. That was 1 minus x into Sn. Therefore Sn is equal to, now simply to divide the right hand side with 1 minus x, and that becomes 1 minus x to the power n upon 1 minus x square minus n into x to the power n divided by 1 minus x. Now let us take another question. Find 1 plus 2 into 2 plus 3 into square plus 4 into 2 cube plus dot dot dot, the last term being 100 into 2 to the 199. This question was set in the Roorkee 1982, and most probably you friends are knowing that the Roorkee is the oldest engineering college in India to now. Now let Sn equals to this thing that we have given sum. We are multiplying this with 2, the same process. The R is 2, so 2 into Sn is this. Let the first equation be 1 and the second equation be 2. Then we are getting the operation 1 minus 2. We are subtracting 2 from 1. So you get, it will be a minus sign, Sn minus 2, Sn means minus Sn. So that equals to 1 plus 2 square plus up to n terms minus 2 into t. Then it's a GP up to n terms. The formula is very simple, the sum of the GP, 1 into 2 to the power n minus 1 by 2 minus 1 minus 2 into 2 to the 1 minus 2 into t n, nth term. Let it the equation be 3. Now what is Tn of this GP? That is the nth term of the AP 1, 2, 3, 4 into nth term of the GP 1, 2 square and so on. So this being 1 plus n minus 1 into 1, we are simply using the formula and multiplied by 1 into 2 to the power n minus 1. So summarily it becomes n into 2 to the power n minus 1. Now from the equation 3, this equation, you get Sn. This is called, I am taking the minus sign to the right hand side, Therefore, the minus 2 to the power n minus 1 plus 2 into n into 2 to the power n minus 1. This 2 power 1, I am clubbing it up. So 1 minus 2 to the power n minus n into 2 to the power n, and that equals to, I am taking 2 to the power n common, it becomes 1 minus 1 plus n into 2 to the power n. Now what is n here? The n is here 100. So place the value of n as 100 and you get the result, the equals of 1 minus 101 into 2 to the power 100. Now let's take another example. This is also a sum from the IIT entrance 1972. S equals to 1 plus 4 by 5 plus 7 by 5 square plus 10 by 5 cube plus so on up to n times. So you know 1 by 5 into S, that would be, this will be shifted by 1 plus on the right hand side 1 by 5 plus 4 by 5 square plus 7 by 5 cube, and the last term being Tn, it will be plus 1 by 5 into Tn. As before, we are subtracting. So 1 minus 1 by 5 into S is equal to 1 plus, we are separating 1 plus 3 by 5 plus 3 by 5 square plus 3 by 5 cube up to n minus 1 terms, because we are shifted 1 term, minus 1 by 5 into Tn. So that is very simple. Ultimately, this comes up to 1 plus 3 by 5 into this thing minus 1 by 5 into Tn. So we need this Tn. Okay, and here comes 4 by 5 into S. Is equal to 1 plus 3 by 4 into this thing minus 1 by 5 into Tn. Now, Tn of the AGP, that will be Tn of the AP 1, 4, 7, 10, and the Tn of the GP 1 by 5, 1 by 5 square and so on. So this is so simple. 1 plus n minus 1 into 3 into 1 into 1 by 5 to the power n minus 1. So if you are going to solve it, that becomes 3n minus 2 by 5 to the power n minus 1. Now you have to multiply this with 1 by 5, you need it. Therefore 1 by 5 into Tn, that equals to 3n minus 2 divided by 5 to the power n. So you see, now it becomes 4 by 5s is equal to 1 plus, well just simplified it to 3 by 4, 1 into 1 minus 5 to the power n minus 3n minus 2 to the power 5 by n. That equals to, this 3 by 4 multiplied with 3 by 4, 1 plus 3 by 4 is 7 by 4. Minus 3 by 4 into 1 by 5 to the power n, and here it is as before, 3 minus 2 upon 5 to the power n. Just you plug it up. Okay. Therefore, S is equal to, we have to divide both the sides with 4 by 5. You have done it. Therefore, it becomes 35 by 16 minus 3 by 16 into 1 to the power 1 by 5 to the power n minus 2 minus 3n minus 2 upon 4 into 5 to the power 1. That was the sum. Now, let us take another interesting sum, and probably the last sum about this video session. Find 1 plus 2 square x plus 3 square x square plus 4 square x cube plus dot 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 up to infinity, where mod x less than 1, that is x is a real fraction. So you see by observation it is clear and infinity series. Let S is equal to the sum of the infinity series, and that is that. Now we have multiplied this with x, therefore it is x plus 2 square x square plus 3 square x square and so on up to infinity. So subtract it. 1 minus x into s is equal to here 1 plus 2 square minus 1 into x plus 3 square minus 2 square into x square plus 4 square minus 3 square into x square plus 1 up to infinity. So you see 1 minus s x into s is equal to 1 plus 3x. Here it is 5x square, here it is 7x cube plus dot 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 up to infinity. That is the equation 1. Now once again we are multiplying this with x. Therefore x into 1 minus x into s is equal to x plus 3x square plus 5x square and so on up to infinity. And once again we are subtracting 1 from 2. And this becomes 1 minus x into 1 minus x into s. That equals to 1 plus 2x plus 2x square plus 2x cube up to infinity terms. Or it will be 1 plus 2x, take common, this will be 1 plus x square up to infinity terms of GP. And that it becomes 1 plus 2x, 1 into 1 by 1 minus x, a by 1 minus r is the formula. And that equals to, by simplifying 1 plus x by 1 minus x. Therefore, s is equal to, you have to divide the right hand side with 1 minus x into 1 minus x, means it is 1 minus x square, divide it. So it becomes 1 plus x by 1 minus x whole cube. So this is the end of this session of our video class. And here I am AKD sir with you in our channel Classes with ILM. Now friends, if you like the contents of my channel and if it is benefiting you, I will be requesting to subscribe, to share or to like my channel. Thanking you.